Hey everybody, it's Dr. J, and today we're talking about Le Chatelier's principle. Let's talk about chemistry. Hey y'all, I'm down here. I'm down here on the bottom of your screen now. Okay. So pressure, volume, and concentration affect equilibrium position, right? But it's not going to impact our equilibrium constant. So the actual number. It's not going to change that number or anything like that. Now, if we change our temperature, that can impact and change our equilibrium constant now. All right. So let's go back to that very first, right? When I was talking about exothermic and endothermic, that's where these are about to come in play. The effect of temperature on a reaction is dependent on whether the reaction is exothermic, as I mentioned, or endothermic. And we understand that if you are exothermic, you have a delta H, right? Enthalpy, and your enthalpy will be negative. Endothermic, we know delta H, enthalpy, right? Our enthalpy of our reaction, he will be positive, right? Absorbing. So we can actually predict the changes by treating heat as a product or reactant on every single reaction. All right, so this is basically if you're changing your temperature, this is what's about to happen over here. So let's look at exothermic reactions. Exothermic reactions, we said delta H is negative. So we also understand with exothermic reactions, our heat will be a product, right? Because we are releasing that energy with exothermic reactions. So when we release energy, we're releasing that heat, right? So heat is a product in this case. So increasing the temperature, so basically we're adding heat to a reaction, will cause our equilibrium to shift back to make more reactants. So if we increase our temperature, we add heat, we're going to shift back to make more reactants. So, right, basically, we need to think about this when we were talking about adding and removing products and reactants. It's the same concept. Now we just have to apply when is exothermic versus endothermic, right? Because now heat is a product or a reactant now, but the same concept before. So if I got a product, if my heat is my product, if I add more heat, right? If I add more products, then which way are we going to shift? We're going to shift towards the right, right, to make more reactants. Now, here's the other thing that will happen. Not only will we go towards the right, right? Well, excuse me. Not only will we go towards the left for our reactants, but our K will start to decrease because we're going towards our reactants. So if y'all remember, right, going back to small K, big K, check out that video. This kind of makes sense, right? Small K, we understand that it's going to be reactants. So we need a small K because it's going towards the reactants. Now, if we decrease our temperature, so in this case, if we remove our heat, we take away our heat, it's going to cause our equilibrium to shift forward to make more products, right? Because you took away my product, so I need to replenish my product. Okay? So in this case, right, if you take away my heat, I need more heat. So in order to make more heat, we're going to go towards the right. We're going to make more products. And once that happens, notice what happens with our K. Our K will increase. Now, does this make sense? Yes, because we said if you got big K, then big K is going towards the products, right? So our K should increase as well. Why is it increasing? Because we're going towards the product, big K. Once again, I highly suggest looking at that small K, big K video when we were talking about equilibrium earlier. So endothermic reaction, we said that delta H is positive. So we're going to be absorbing energy, right? We're not releasing like exo, right? XO, shout out to OVO, where Drake at? All right, anywho, endothermic reaction, we said that we're absorbing energy. So in this case, right, our delta H is going to be positive. So if we're absorbing energy, we gotta treat it as a reactant now. So for endothermic reactions, heat is a reactant. So now if heat is my reactant, what's going to happen when I add heat or if I take away heat. So if I increase my temperature, right, if I add heat, then this is going to cause my equilibrium to shift to make more products, right? Because I'm adding more reactants. Just like with the same concept mentioned earlier here in the video. Now understand, right? Let's look at our K. The K makes sense now, right? If I'm shifting to make more products, then I need to have a big K because I understand that big K means that I'm going towards products. The bigger the K, we're talking about the direction going towards the products. So our K should be increasing because we're going towards the products. What about decreasing the temperature? If I'm decreasing the temperature, that means that I'm removing my heat, right? And if I'm removing my heat, if I'm removing a reactant, right? If I'm removing my reactant, this will cause my equilibrium to shift back to make more reactants because you took away my reactant. I need my reactant back. Okay. So this is what's going to happen here. Take away my reactant is just being replenished back here. Now also pay attention to the K. We need to understand that if we're shifting back towards the reactants, am I going to have small k? Yes, right? So if I got small k, my k is decreasing over time. All right? So everybody, this is how you need to look when you have an endothermic or exothermic reaction. Anytime that you're changing that temperature, your k will change with it. Another thing you need to understand is, you need to understand if you got an exothermic reaction, your heat is a product. Once you know your heat is your product, just do it like we did earlier. If you add products, right, that's going to determine where you shift. If you take away my product, that's going to determine where we shift. Same thing with endothermic. If heat for endothermic reactions is a reactant, just treat it like a reactant. If you add a reactant, it's going to shift a certain way. If you take away your reactant, it's going to shift a certain way. Okay. So this is our Le Chatelier's principle, and you want to make sure you understand which direction it will go when you add these different stresses towards your reaction. So let's look at an example, right? Change in temperature. Once again, we still got that same equation, N2O4 plus heat gives me 2NO2. All right, so this is what it's actually looking like. Let's just look at it, right? So right now, it's in ice. It's cold. It's cold right now. Lower temperature. Understand that this is endothermic right now, so therefore, my heat is acting as a reactant. All right. So, so let's look at this again. Let's look at this equation again. This reaction N2O4 plus my heat gives me 2NO2. So this is a endothermic reaction. This is straight up an endothermic reaction. How do we know it's endothermic, Dr. J? Because my heat is a reactant, right? We're absorbing heat. So what do we do if we increase our temperature or decrease our temperature? Which direction will our equilibrium adjust to? Which way will it go when we add this stress to it? So when I lower my temperature, let's say I put this in the ice bath, what's going to happen to my reaction, right? Because right now, as we mentioned, heat is a reactant now. So if you lower your temperature, right, if you take away that heat, right, you're removing your reactant. And if you remove your reactant, then remember, you got to replace that reactant. Okay. So because our reactant is on our heat is on our reactant side, we're going to have to shift towards the left to replace our reactant. So in this case, it's a shift towards the left. Now also understand, because we're shifting towards the left, how's that going to impact my K? My K is going to become smaller, right? Because small k is on the reactants. But if I add my heat, right? If I add my heat, what's going to happen now? well, my heat's still on my reactant side, but if you add heat, if you add reactants, it's then going to shift towards the products, right? So in this case, if you add heat, it's going to shift to make more products, NO2. And also because it's shifting to make more products, RK will gradually start to increase as well because it's big K. All right. So once again, depending if you have an endothermic or exothermic reaction, that's going to impact everything, everybody. Once you know if it's endothermic or exothermic, just treat so depending if you have an endothermic or exothermic reaction, that's going to impact everything. Once you know it, then you could treat your heat as a product or a reactant, right? And then when you go to add heat or remove heat, that will tell you which direction it's going to shift. This is the different stresses for Le Chatelier's principle.